Hello everyone, this is Surendra. Today I am going to explain about my project GameMind Behavior Analytics and Prediction for Gamers. The GameMind project leverages data analytics and machine learning techniques to analyze and predict player behavior in gaming environments. By simulating gaming data, it models real-world scenarios where uh, game developers and publishers can monitor and intervene based on the user's in-game behavior, such as session length, toxicity levels, and engagement. The project addresses concerns like player burnout, toxic behavior, and game addiction by predicting these behaviors early on and ensuring that developers can take proactive measures. Key uses of this project are player segmentation. It classifies the players into different behavioral segments: casual, regular, and addicted, allowing game developers to better understand player motivations and engagement levels. Early warning system. It provides alerts based on detected patterns of behavior such as excessive playtime or toxic interactions, helping developers moderate use behavior effectively. Improved game design. By analyzing these patterns, the project can suggest changes to game's design on user interface to improve user experience by reducing the toxicity and encourage the healthier game habits. Real-time analytics. The dashboard allows for real-time tracking and visualization of player metrics, giving insights into trends like toxicity or excessive gameplay. The goal of the project is to provide actionable insights into player behavior that will ultimately enhance player satisfaction, ensuring healthier gaming environments, and optimize the game performance. Moving on to the code, in the first cell, we generate the data, like we generate a synthetic data of for the users with different game types and game IDs with different sessions per day, sessions per length, mean, and difference by using random. And in the second cell, we load that data into the code and reprocess the data by extracting the player ID, check if the file is existing, and we preprocess the data into numerical and categorical type. And we take averages and maximum and other stats of the data and we calculate daily stats and get average daily stats and merge all user features into a single user feature .csv. Then we extract sequence features. We sort the data by users and time. And then we again combine that data into user data with time based or in sequence it is saved. It then displays the first few rows of the data in this order with total sessions and everything and maximums. Now moving on to the cell 3. This cell is focused on building a machine learning model that can classify gamers into low, medium, or high risk of problematic play based on their behavior patterns. The data is loaded and prepared for the analyzing by metrics like average session time, night sessions, and etc., along with labeled risk levels. We use standard scaler to normalize the features so that the classifier will perform well without any issues. Model selection and training, we have used a random forest classifier is tra- trained, which is ideal due to its robustness and interpretability. Hyperparameters like n estimators, here it is, Here, hyperparameters like n estimators and random state are given with a max depth and class weight are tuned for balanced performance across the classes. It splits the data into training and testing sets of 80% and 20%. And for accuracy, we have used classification report and confusion matrix. And ROC and AEC curves to visualize performance per class. We have used them. And then after that, the model is saved for later using real-time quick prediction. This cell mainly evaluates a model that turns users' metrics into risk predictions and prepares everything we need for live detection. And here we use k-means clustering for analyzing the clusters according to the sessions of the users. In the cell 4 here, like this, the users are grouped into clusters. In the cell 4, we bring the model to life and integrate into real-time behavioral monitoring and warning system for gamers. In this, the key components are model and data loader, session processor, and feature extraction, and risk prediction, and warning generation, and simulation and analysis. In model and data loader, the previous models, risk classifier and feature scaler, are loaded along with the data. The models are used loading job live. And then session is a new session handles each new gaming session, processing the gaming details. The logs details like start time, duration, if it's a night or weekend session. And it also tracks session to session behavior. Example, short breaks and time between the sessions. And it keeps updating the user history stored in a dictionary according to that. And then features are extracted from the given data. This calculate user features is used for calculating the features which convert session logs into metrics like average session time, night ratio, and total play time and frequency of the play and etc. These are the same features used during the training in the cell 3. And then the sessions by date and length of the sessions, we assess the sessions with the average and minimum time and maximum time between the sessions. And then we assess the risk, like risk prediction, by applying the training model to predict the current risk level. And it also returns the probability of the risk. And then the warnings are generated according to the risk generated in the risk generation. If the risk level is medium or high, a personalized warning is generated. Tailored insights like high night play or short breaks and actionable tips are included. Warnings are logged for further analysis, so they are saved for future insights. And then uh, it creates a mock user behavior, low, medium, and high. The simulate user session creates mock user behavior, low, medium, and high risk, and calls the full pipeline and counts how many warnings are generated. The analyze warnings function is used to analyze the and visualize the warning trends by day and risk level. In this, a full behavioral monitoring system from session logging to real-time task risk prediction to actionable user warnings, making it core of the early intervention strategy. And the data is saved for plotting it into a dashboard. And then in the final cell, the data is loaded from the previous saved data files, and according to that, different kinds of flowcharts are generated here, in which there are user disk distribution, gaming sessions over time, session duration distribution, and warnings over time, and session time heat map and feature importance are generated for the dashboard. By the data, we have modified and clustered and analyzed, and we have used HTML code for uh, creating the dashboard of the creating a similar dashboard to a Power BI because of the issue with the Power BI, and we have saved here overview risk distribution. With risk level low, the count is 66 out of 100, and with medium, there is 5, and with high, it is 7, and some values are removed, which are null values or data inconsistent. And then the second chart describes about sessions over time, like gaming sessions over time for a user. We can see on that February 21, 2025, number of sessions are 109. Where on February 23, it has risen up to 156. Like it shows the visual representation of the sessions of the user and session duration distribution. Maximum the sessions are 20 minutes to 40 minutes, as we can see it from the session duration distribution. The session duration with 260 minutes to 280 minutes is low, which is very good, but it should not be more than a 30 minutes or 40 minutes session. And gaming session heat map. The heat generated due to the gaming of in the mobile or the PC. This gives the hours and the days of the week and number of sessions is generated. And feature importance. The feature importance of the risk assessment. These are the attributes or the features: night session ratio, weekend session ratio, and play frequency, and maximum average every time. This is a total play time, and these are the warnings generated over time. Maximum there are medium warnings, but sometimes there are also high risk level warnings, which is dangerous to the health. That's it. Thank you.